Hi, everyone who's joining us on our live streaming today. Here is myself, Olga. I'm the CEO and founder of Toloka. Together with me today is Renaud, our director of agentic programs, and one of the few people on the earth who's been dealing with a new type of data for developing and training AI agents for already quite a long time before it became a buzzword. So today we'll talk about the evolution of training data for AI and how we are entering the new era together with the development of AI agents and RLGMs and all the new popular approaches towards training AI. So we've got lots of interesting topics to discuss. Please feel free to share your comments, your questions in the chat. We will be looking from time to time at the questions in the chat, and Renaud will definitely answer the majority of them because Renaud is super smart. I think that we at Toloka, we've been in the industry for quite a long time already, and if there is anything that is constant in our industry is that it's constantly changing. Indeed, several years ago, it was enough to be just any human to share some valuable signal with AI. A couple of years ago, it was enough to be just PhD professor in physics to be able to train chatbots to detect fact-checking mistakes and to share their academic knowledge with the large language models. But now even those days are over. Now you need to be an practicing professional acting in a controlled environment in order to be able to generate the useful data that is later used for training and evaluating AI, how it works now within AI agents while communicating and interacting with different tools applied on different surfaces and etc. So Renaud, how do you feel about this evolution? What are the latest types of the demand that you are seeing from our customers?
Most of our customers are very much focused on what has been the latest scaling law in terms of AI capability, which is the RL part of the whole model lifespan. Pre-training, that stuff, pretty clear. All the internet has been scooped up, so not gonna be much more gains there, even though there's still stuff to be done. Post-training SFT, getting it to be a good enough chat app. That also pretty clear. There's a ton of SFT data already. But it's the reinforcement learning in order to really improve its capabilities with reasoning, where there's most to gain right now and where most of the industry is scaling towards because of data availability, compute availability is the last scaling law we have right now. So everything that goes in the direction of creating environments, hence the name RL gyms, for reinforcement learning with verifiable rewards and not human feedback like we did 6-8 months ago, is indeed where the industry is going as a whole, and more specifically, leading labs are leading the charge on this. You can clearly see based on how far ahead their internal models are, where in this whole life cycle they are. If you are very early, nobody's kind of training foundational models right now. So the pre-training data is not so much in demand. But the further you are in your model capabilities, the further you are in this model lifecycle. People that are starting to do agents, that have foundational models, but they're not very agentic still, not very good at calling tools. They're asking more for SFT data using tools because tool usage is not something you can find on the internet. So you need to start somewhere and have very specific SFT data in order to elicit tool use in your agent, in your LLM. Once you have those, indeed, you shift into these more RL gym type data sets where the agent can go and train itself by trying and seeing if it improves across these different benchmarks and gyms. And even then, even later, once you have apps in production, how do you continuously learn? That's also something we offer. Going in and looking at the transcripts of your LLM and trying to correct them, improve them so you can continuously learn on them, add more test cases to your RLVR set, RL gym, so that you continuously learn and improve your model on the feedback you get from the world as it's deployed. So
Yeah,
based
all
on
the
how far away
spectrum.
you are, you progress through this kind of linear tech tree.
And yeah, all the spectrum. And it's interesting to be in a position to be able to see how different players in the industry are tackling those challenges. You have mentioned benchmarks, and I think that that is one of quite a decent types of the demand that we're seeing. And can you elaborate on that? Because there are so many publicly available benchmarks. Like on the latest ICML conference, I know, I would say every second, but I think it is even more. Like almost every paper was about creating some new type of benchmark. Uh, so everybody seems to be creating some publicly available benchmarks, and still we do see the demand for privately, specifically customized benchmarks from our customers. How do you explain that?
Um, so two main reasons. One is the fact that, unfortunately, for public benchmarks, as soon as they are published, models will tend to overfit to them because the benchmark is publicly available, and as a result, it's too easy for AI labs. Ergo, Meta's mistake 4.5 months ago when they released Scout and Maverick, where they had a specific tuned version that has very good scores on publicly available benchmarks. If the benchmarks aren't public, there's no longer an issue. Um, that's one. And two, it's a question of volume of data. Um, Overall internet, overall SFT data, even because SFT has been done for the last 2, 3 years already. There's a ton of it. Um, RL data, benchmark data is still a drop in the bucket compared to the other two. So if you really want to create some good instances, environments for your models to learn and train themselves upon, um, you need a lot more. There's a volume argument. I mean, you need a lot higher quality. Um, See the latest publications from around Sonnet 4.5, where the model is detecting now that it's being evaluated, and as a result, it's changing its behavior. So the environment has to be as realistic and of good quality as possible, because if you do basic curation instead of creation of existing data, it's not very realistic. And as a result, it's also hard to make those into a good enough test case for the agent to train itself upon.
Yeah, absolutely. You can only improve something when you are consistently evaluating that. And I would also support the fact that creating high quality data is like we are seeing that the requirements towards the quality are becoming higher and higher, and the complexity and I would say the uh, expensiveness of creating every additional percentage point of the quality of the data item is just crazy. Coming up with a data quality of 99% is exponentially more expensive than like 90%. That's why I can understand why it's really hard to find open source benchmarks that would really be hitting this level of quality. Uh, so yeah, that's super interesting. What are the major, I don't know, task types or data types that you are seeing?
Um, all of them fit in the same high level framework of you have a user intention, create me a piece of code, solve this particular issue I have. An agent that has access to a bunch of tools. Maybe it's writing some code. Maybe it's querying a database somewhere. Maybe it's using MCP tools to do something for the user. And what makes it VR is the verifiable reward part, where you have automatic grading, deterministic, ideally, or a blend of deterministic and LLM judge, so that you improve. You have a good signal as to if you succeed or not. Ideally, as well, this verifiable reward is not binary. It's not success fail. It's some sort of a grade, so you can do RL. So inside this, indeed, we see 4 or 5, depends on how you count, main types. Most of it comes to what type of failure you try to elicit and what are the class of tools the agent has access to. For coding, there most of the types are going to be that's a clear, distinct type of tool, and there the type of failure you can elicit are either safety failures, where you're leaving the agent to have access to something very, very sensitive, which is your own computer, your own server. So the safety aspects are extremely important, and we clearly see that agents have a lot of work to do to get safe enough to be deployed at scale there.
At the same time,
And
they are progressing greatly, right? You
yeah,
remember
exactly.
how we did some of the first red teamings of computer use agents back, I think, in the end of the year 24, and they were in a way so naive, and now the progress is just amazing.
Yeah, exactly. Safety, capability. Is it a good coding agent? Can it code properly? Can it completely convert your code base from one language to another? Can it make its changes in a minimal amount of changes to the code base? Measure twice, cut once, etc. Coding effectiveness. Second bucket of types of agentic data would be everything regarding customer support. Very easy uh, type of deployment for an agent. Customer support. Customer can be an external customer, internal customer, B2E, whatever. Using a lot of MCPs typically, and there, indeed, safety is not so much of an issue. It's mostly about, is the agent able to navigate the complex nature of that specific environment, the jargon, the industry knowledge, the processes it has to follow, given tools that are realistic to the industry state currently. And dealing with all of this is unfortunately something AIs are not very good at. Um, and but here the failures are going to be mostly about following complex industry policies, failure to call tools properly, etc. And finally, we have another type, which is everything regarding browser use, computer use, where we're testing more the multimodal aspect of the agent. And here we clearly see that one, same with coding, you're asking the AI to control something pretty sensitive, huge amount of safety issues that need to have a dedicated reinforcement learning environment for it to learn not to do dangerous things. And also in the efficiency part, where, I mean, for an AI to understand a web page, click on the right things, we clearly see that it's not just the LLM capability, but also the harness of tools that you need to deploy as a provider. Um, there's a lot of work to be done. And the fourth bucket, a bit different, but still kind of fits, is everything regarding knowledge retrieval. Yes, knowledge retrieval, a lot of it has been done very well. We have RAG systems. It works well for big databases and straightforward asks. Um, but it's the blend of knowledge retrieval and solving an issue for a user where agents tend to break down because this knowledge search is like quickly overloads the context window of the agent. And if it has to go search through 5, 6, 7 documents to find the answer and then call the tools properly, this introduces a lot of variability on the agent's ability to complete the task. So computer use / browser use, knowledge retrieval, customer support, and coding, like those are the main functional pillars. And then you always have safety and effectiveness as the types of failures you're trying to detect.
Oh, cool. So yeah, and that's probably something a little bit counterintuitive, but you are basically targeting on quite a specific range of failure rate, right? In some cases, yeah.
Yep.
Just tell a bit more about that. And while you are preparing for the answer, I would address our audience. Please don't hesitate to ask questions. We've got 15 minutes more of this discussion, so would be happy to answer your questions if you have any. Meanwhile, Renaud will tell us more about the failure rates.
Yeah. So indeed, the requirements for a benchmark and the requirements for an RL gym, while the test cases will look very similar, the actual failure rate that you target is very different. For a benchmark, you want to make it as hard as possible so it'll stay in the zeitgeist as long as possible because it's not saturated yet by current LLMs. For RL, you have to be much more fine-tuned and you need to aim for roughly a score of zero point 0.5 or roughly 50% failure rate. Why? Because if it fails too little, there's barely any value for the LLM to train upon it. And if it fails too much, it doesn't give a nice enough slope for you to do RL. So you have to iteratively tweak your tasks to target this very specific failure rate in order to maximize your RL's effectiveness, which is also why benchmarks currently have a shelf life, and RL gyms currently have a shelf life, and we expect most of our clients to come back for more, basically, because they will have to.
Yeah. We've got an interesting question from the audience about training agents on users' behaviors data. But I think before we jump into that, we should cover still the question about training agents on the data which is collected within controlled environments, because these are the most frequent use cases we're dealing with, something similar to Tau benchmarks and all the new generations of similar idea, something similar to virtual companies and creating virtual environments. Can you please share something about that?
Yeah. So how do we make it realistic, this environment the agent behaves in, so that one, as we've seen with and latest anthropic models, it won't detect it's being tested, and two, it will be realistic to how it will behave. It will have to behave in the real world. Um, I really like the analogy of initially we had random people in from the world, then we have PhD level. Now, basically, what we're finding is no single human has all the capabilities required to even deliver those items, and you have to break it down into pieces. So to guarantee realism, let's imagine you want to create an agent for a healthcare type environment. You would need to break it down into three at least, maybe a bit four. Big three are, and they're done in order. You have to scope out the agent. What is it for? How does it work? What tools would it have? And this you have to do with business people from healthcare. So you need to find doctors, nurses, administrative staff, all of these people, squeeze their brains so you can scope out the agent, what tools, the jargon, high level the scenarios that you're trying to build in this particular domain. Business SMEs. Then you actually have to build the agent. And to do this quick and at scale, you need coders that will then code all the specific tools, code up write the system prompt in a way that a typical coder would develop it in that particular industry. And finally, and this is the key ingredient, you need people that have a lot of experience breaking agents, because there's a bunch of tricks that you can kind of reuse. You have to understand how the LLM will access the data, how it will call the tools, how the LLMs behave when in an agentic context, to craft test cases based off the scenarios of the first group using the code of the second into coherent test cases in which you will be able to do RL. And that third group of test case builders, for lack of a better word, are more like the CV would be something like prompt engineer is no longer a right word because it's no longer about prompt, but it's like context engineering, LLM enabled type of users that do not necessarily need to have deep industry knowledge because they benefit from the transfer from the first group. And finally, the fourth one is however good your harness, however good your test case, looking at a test case by itself, it's very hard for us humans to say, hey, will this be super trivial for the LLM or will this be hard? Because the test case itself is fairly, they look okay, okay, this one requires 5 tools, this one also requires 5 tools. User intent is rather similar in both. One will fail 90% of the time, the other will succeed always. So the only way to get quickly an understanding of is it a good test case or not, is the agents failing for the right reason, or is it failing because it's a non-deterministic process and we were just lucky when you ran it 10 times? You need to go look at the transcripts. So we have the fourth group deployed, depending on if you need it or not, of annotators to go and read all the transcripts, identify, okay, here's where the agent failed, here's why. Is it a good failure, a bad failure? So we can take this and loop it up and produce as much of these enforcement learning test cases as possible.
That sounds really amazing to me because, on the one hand, the world has changed so much, and the data items that we are producing now are so far away from the classical days of crowdsourcing when Toloka started, when the one effort of human annotator took like 30 seconds at maximum. And now we are talking about hours and sometimes days, or even not more of efforts of humans to produce a data item. But at the same time, some ideology stays the same. You still need decomposition and targeting on specifically special expertise within human experts to deal with their own piece of the pipeline of the data generation. But the very common question that we hear quite often is, why do you need humans at all in this process? Cannot you just automate it? Cannot you just rely on fully synthetic data or on users' behavioral data?
Yeah. So, I mean, back to the model lifecycle view, you're doing this RL stuff before you're releasing a new model. So you don't have a clue, you don't have user data yet because it hasn't been released. So already there's no user data to be used. But assuming there was, um, you don't really care about the 90% where you know your agent is going to succeed. You care about the 10% where it doesn't, because that's where you need to train more. So you will handle these edge cases and you will get to multiple nines of reliability, which is the holy grail of AI systems. Um, so could you use purely synthetic? Long term, yes. We don't use only humans. We use both. We're a pure hybrid of LLM and human. As LLMs improve, out of this composition in 3 main buckets, all of these are actually subdivided into sub buckets and sub buckets. And the goal for us and for the industry and for like interacting with AI is always the same, whether it's data creation and fine tuning and or it's I don't know, like writing some code in a company. It's always going to be certain tasks currently are being done by AI because AI is perfectly good at them. Certain tasks better done by humans, much faster with humans. As AI improves, some tasks will be shifted to AI that were done by humans previously. Um, and it's human of the gaps. You have your full pipeline as we are set up right now. It's roughly in terms of input, it's mostly human, but it's still a good 30-40% AI on average. As AI improves, this will shift.
I
But
know that you, Renaud, are the techno optimist in our team, and I know that there are constantly internal friendly fights between those who double down on creating like pipelines based on human efforts, and someone named Renault who tries to automate as much as possible, and always the who wins is unclear. Usually, as far as I know, we end up doubling down on human experts because when you need this 99% quality, it's really hard to achieve it without really human oversight and insights.
yep,
Um, yeah.
let's maybe shift to the questions rapid fire. Have we tried using training agents with users' behavioral data and purchase behavior? This one is so we have helped in that we have some of our clients that bring these user traces and ask us to build those into RL gyms or specified like data sets. So yes, however, again, you cannot anticipate what the users will do next. So hyperfixating on what users are doing right now, it's good to ensure diversity of your data set and make sure you at least cover this. But hopefully your data set covers a lot more than this because users are as non-deterministic as LLMs, at least. Um, so case of training agent for systems with hard constraints. Um, so depends on how you build your agents. Um, the constraint handling can be done at the tool level, or it can be done inside the agent. Best practice up until now has been try and keep as much as much of it that can be deterministic. If it's like a check against a certain constraint, it's always better to keep the deterministic stuff in the tool and have only the non-deterministic stuff handled by the agent, as it is for humans. Basically the same. Like if you're doing a planning change that would have ramifications on your plan, that would create conflicts in your plan, you don't want to have the agent determine if there's a conflict. You want the tool to feed the info like, hey, there's a conflict if you do this. So the agent continues to do its thing without having to do this deterministic stuff, because why have it be done by the agent in the first place? Um, any methods to support training in systems that need to respect physical restrictions? Um, for this, it kind of is in the same vein of the previous question. If there's physical feedback that you can provide through a tool and have that physical feedback be done hard coded in that sense, it's much better practice to have it done there than it is to try and make it understand to the agent currently. Um, because of there's a lot less randomness that way. Uh, you're sure of the physics, you're sure of the have it be there and have the agent do the other tweaks around it instead of um, desperately trying to make it understand things where it's not currently very well equipped to do.
Thank you, Renaud, and thanks for this very fast answering of the three last questions in our Q&A sessions. I want to thank everyone who's attended our webinar, and I want to thank Renaud for sharing his experience. Hope it was useful and interesting. Again, thanks for coming. We will be happy to help any one of you with your requests and challenges related to training AI agents. See you next time. Have a good day. Bye bye.